This week, you're going to learn about logarithmic and exponential equations. There's a couple of different ways we can do this. The first way is to try to get the bases on each side of the equal sign to be the same. For instance, here, if you could get this b and this b, if you could get those to be the same number, then in that case, if those are the same number, then the exponents would just equal each other. So the first thing you would want to do is try to get the numbers to have the same base. Then set the exponents equal to each other, and then solve as you would any other equation. All right, let's try an example. Let's look at A. When we look at A, we have a base of 2 on the left, and we have a 16 on the right. You would want to make sure you're trying to make your base a smaller base number and increase the exponent. So you'd be looking to make the 16 into a 2, not the 2 into a 16. So can 16 be written with a base of 2? Yes. 16 is 2 to the 4th. So because you can get both sides with a base of 2, you can just set the exponents equal to each other and just solve it like a regular old equation. And if you put the 4 back in here, you see that you'll get 3 times 4 is 12 minus 8 is 4, and 2 to the 4th is 16, so that works. All right, let's come over to the second one. You actually can't easily, anyway, turn a 27 into a 9, but you could change them both into a base of 3. So 9 is 3 squared, and 27 is 3 cubed. That's a little hard to see. So this is 3 cubed, so the exponent is x plus 3, and 9 is 3 squared, exponent x minus 1, and then you can distribute this exponent to the other exponent, because this is a power to a power. Like if you had x to the 5th to the 3rd, that would be x to the 15th. You would multiply these. So that's what you're going to do here. So 3 to the, that's going to become 3x plus 9 equals 3 to the 2x minus 2. And now that you have the same base, you can set the exponents equal to each other. I'm going to subtract the 2x. I'll subtract the 9, and I get negative 11. Okay, now I would like you to try the next two and get back to me. So pause the video, try these, and then see if your answers are right. Okay, hopefully you discovered that 125 is 5 to the 3rd. And you got x is 3. 8 and 4 can both be made into a base of 2. And then distribute that exponent. Same bases, so exponents are equal. Subtract 2x. And subtract the 6. We get x is negative 12. So that's one way you can solve exponential equations. But as you probably realize, you can't always turn one number into another. You can't always make them the same base. So we have to have a backup plan. So this is where the logarithms come in. Logarithms are what you use to solve an exponential equation, because logarithms are the inverse of exponents. Okay. So if you have a situation, and you can look at this example down here, you're never making that 15 into a 4. It's just not going to happen, so you got to have a backup plan. So the first thing you would want to do is isolate the exponential expression. So just get the 4 to the x by himself. You know, if there was like a, you know, a plus 3 on that side or something, you'd want to get rid of that first. the next thing we do is we take the common log on both sides of the equation. That's for base 10. You can actually take any log you want. You could take a log base 2. It doesn't make any difference as long as you do the same log to both sides. Their instructions from the book say take the natural log for bases that are not 10. But as I just said, it doesn't matter what log you take as long as you take the same log on both sides. And then you'll simplify. So if you have ln of b to the x, that's going to equal x ln b, right? Because the exponent comes out front. That's what we practiced last week. Excuse me. Or ln e to the x equals just x. If you remember, the x comes out front, but ln e is 1. So ln e to the x is just x. Or log of 10 to the x is x, similar to the ln, in that the base down here is 10. So you could say 10 to the x equals 10 to the x. Or you could bring the x down in front, and log of 10 is just 1. So, okay, and then solve. All right, so it'll be easier in practice. Okay, so the first thing you want to do is see if you can make the 15 and the 4 have the same base, but you can't. So your variable is in the exponent, and in order to solve for the exponent, he's got to get out of there. You're never going to find x if he's stuck in the exponent. So we're going to take the log of both sides, just like we would add 5 to both sides or divide both sides by 13 or whatever. We're going to take the log of both sides. Okay, log is an operation just like multiplication is. So you can do whichever as long as you do it to both sides. Now, you learned last week that an exponent here, that can come out front of the log. And the purpose of this is, do you see that x? It's not stuck in the exponent anymore. It's loose. So now we can just divide by log 4. And x equals whatever log 15 divided by log 4 is. It depends on the directions, how they want you to leave the answer. If they say they want the answer to be exact, then this would literally be the answer. This would be exact because there's no rounding involved. But if you were to type it in a calculator, which I'll do now, we get 1.95. Again, read the directions, round to whatever place they ask you to. I know they ask you to round it differently on every single problem. Just read the directions. So we'll go to the third decimal place. Okay, let's look at B. X is in the exponent. I'm not going to make 120,000 into 10. That's just not happening. So I'm going to take the log of both sides, but this is going to be better because the base of this log matches this base. That's going to make it much better. So this x will come down in front. Oops. Equals log of 120,000. And then divide by log 10, except log 10 is just 1. It's just 1. This is 1. So x just equals log of 120,000. And if you needed a decimal for that, it would be 5.079. But if it says it wants an exact answer, then this is exact. Okay. So why don't you try these, pause the video, and you try these two and get back. Okay. So we'll take the log of both sides, and we get x log 5 equals log of 134. Divide both sides by log 5. log 134 divided by log 5. Which is 3.043. I'm just going to stick with 3 decimal places for now. Okay, next one. I'm going to take the log of both sides. I get x log 10 equals log 8,000, but that equals 1. So x is just log of 8,000. X equals 3.903. And you could take the same exact problem but do natural log instead. It doesn't matter, you're going to get the same answer. You'd have to then divide by ln of 10. You didn't have to do that here because the base matched, the base of the exponent matched the base of the log, but but they don't, you know, they don't have to match. That just creates another division step, sorry. Okay, these are just slightly more involved. You just have to do, you have to just do some other stuff first. So the exponential part of this is e to the 0.6x. That's the exponential part. The other stuff is fluff. So get rid of all that first. So we'll add 3 to the other side. Next, we'll divide by 40. Now, what kind of log do we want to take of both sides? So here we have an e. So if you have an exponential equation whose base is e, your best bet is to take a natural log. But again, it doesn't really matter what log you take. So that's going to take the 0.6x out front times ln e equals ln 6. But ln e is 1. So 0.6x equals ln of 6 divided by 0.6. And that is 2.986. Okay. You try this one. I don't know why they have so many directions there, but... Oh, it says 2 decimal places here. Fine. Okay, you try that one and get back to me. Okay. So first, you should be adding 5 to both sides. And then dividing by 7. Take the natural log of both sides. 2x comes out front. Ln e is 1, so that's gone. And divide by 2. So x equals ln of 9 divided by 2. And as a decimal, that's 1 point. Well, they want it to the second decimal place, so this is what my calculator says. This is the second decimal place. So the 8 is going to turn the 9 into a 10. Cool. All right, let's look. Oh, what is this madness? Okay, now I have exponents all over the place. First, though, you always want to see if you can make the bases match, but you're not going to turn a 5 into a 4. So that's not going to work. So the first thing you're going to do is take the log of both sides because you're kind of stuck with nothing else you can do there. So that's going to take this entire exponent and put it out front of the log. Okay, now here's where it gets a little bit weird. I want you to remember that log 5 or log 4, those are just numbers, but they're not pleasant numbers. So it's actually easier to just write log 5 because log 5 is 0.6989700043. Do you want to write that number down? And if you round now, you'll seriously mess up your answer. But remember that log 5 is a number. So x's on both sides are stuck in parentheses. Let's say, you don't need to write this down, but let's say you had this. Let's say there was no log, it was just 4. And you had to solve this equation. What would you do? You would distribute. I know you would. You'd get 5x minus 10 equals 8x plus 12, and you'd go from there. There really isn't any difference. The only difference is that it's not a 5, it's log 5. But that's okay, you just write the word log in front. So you're going to take log 5 and you're going to distribute it to the x and to the 2. And likewise on the other side. So you're going to get x log 5 minus 2 log 5 equals 2x log 4 plus 3 log 4. Okay, so come down and look at this baby one. What would you do next? You would have to get the x's together, right? You can't have x's all over the place. So where are your x's? You got one here and you got one here. Well, they're going to have to get on the same side. They just can't be all over the place. So I'll subtract this one over here. Or you could do it the other way. It doesn't matter. I'm going to have to get rid of this now, though. It's in my way. Okay, so it's gone from the left. So I have minus 2 log 5 equals... Now, these don't have the same log part, right? Like log 4 and log 5. So I can't physically subtract these. But at least they're on the same side now. Okay, now which term over here on the right doesn't have an x in it? This guy. So we're going to subtract him over to the left. And again, we're not really combining them. We're really just moving people around. Okay. Now my x's have got all this log stuff around them. Yes? Okay, so you want to sort of extract the x from these other numbers. So it's like factoring. We're factoring out an x, and we're going to be left with 2 log 4. We're factoring out the x, and we're going to be left with just log 5 and a minus. Now the x is almost alone. So now I have to divide by this mess. Now this process of solving when you just like can't actually combine anything will be very familiar. In calculus, you have to do solving like this all the time. So it's even though it won't be with logs, it's the same kind of process. So x equals this. Okay, if we want to know an answer for that, we're going to have to go to the calculator. But you do need to be smart about how you type it. So you do need parentheses around your entire numerator and your entire denominator. Or you could use the little fraction button on the calculator. If you remember, that's alpha y equals, and then you just select the first one. That's probably the easiest way to do it. And don't forget to close the parentheses around the log number, because you know when you type log, it opens the parentheses, so you have to remember to close it. Is that a minus on the bottom? Yeah. Log 5. So I got -6 point... Did they tell us what to round to? The next one says 2, so we'll do 2. Okay, I hope you got that too. All right, I know that's a lot, so let's move on. We'll try another one. Okay, so same setup. First, we're going to take the log of both sides. The exponent comes out front. Then we distribute. We get the x's on one side and the non-x's on the other. So x log 7, I'm going to subtract to put on the left. And minus log 3, I'm going to add that and put it on the right. Okay. Now I'm going to factor out this x. And then we'll divide by basically all the stuff that just isn't x. It definitely takes practice, but the steps are the same all the time, so it is doable because you just get better at it. Log 7 plus log 3 over 2 log 3 minus log 7 is 12.11. Okay, now we have the weirdest of the log equations, personally, I think, or exponential equations, rather. And that is, these look like quadratics to me. So I think that we did this in some other scenario. Oh, we did it with trig. That's where we did it. So we took this middle guy, except for he was like sine x or something, and we said, we're just going to call him A. So we're going to say e to the x equals a. So that's going to make that middle term negative 4a plus 3 equals 0. That's going to make e to the 2x actually just a squared, because if you had e to the x to the 2, that's e to the 2x. Now this is easy for you, right? Just a little factoring problem. A equals 3, A equals 1, but A wasn't for real. We made up A. A is really e to the x. So then we replace the a's with e to the x. And then you'll have to solve for x. You can take the log of both sides here, or, well, the natural log would be smarter. But you could also just change this to a log equation, like you did last week. So ln e, no. Yes, no. Wait a minute. Got myself all confused. A log with a base of e of 3 equals x. There we go. So that's x. It's just ln 3. I'll do it the other way over here, though. If we took the ln of both sides, I'd get x ln e equals ln 1. Ln e is 1, so x equals ln 1. But ln 1 is 0. You have to know that. So, or if you look up here at this gray line, e to the what is 1. Well, it would have to be 0, because anything to the 0 is 1. Okay, so let's try this one. We're going to say e to the x is a. Then we're going to change our exponential equation here to a squared minus 8a plus 7 equals 0. E to the 0 is 1 because anything to the 0 is 1. And ln 7 equals x. But you could take ln of both sides. X ln e equals ln 7. Okay. So those are exponentials. Now let's talk about logarithmic equations. So if you look back at all the examples we did, x was always stuck in an exponent, and then we had to use logs to get them out. So now it's going to be the reverse. The variables are going to be stuck in a log equation, so we'll have to use exponents to get them out. Okay. So the first thing you want to do is condense and isolate the log. So you want one side of the equation to just be log of something. And that's what that step is indicating. Excuse me again. Then, with the exponents, we take the log of both sides. With when we're doing the logs, we don't exponent both sides, really. We just change it to an exponential equation. I mean, you could say, I'm going to put both sides, as the exponent to a base of 10 or something, but it's just not really how most people think about it, I think. So you're going to rewrite the log equation as an exponential equation, meaning that if you have log base b of m equals c, you put the c as the exponent on the m, and that equals, nope, you put the c as the exponent on the b, and the answer is the m. Apologize. And then you would solve. The problem with log equations is that you have to check your answers. Sometimes you get extraneous solutions. So that is something you have to be aware of. Okay, let's try one. Let's look here. I have one log on the left side, so that's good. I can change this to an exponential equation right now by saying 4 squared equals x plus 3. That's 16. Subtract 3, 13. I'm done. Okay, let's look at this next one. You actually have some options here, but I'm going to say let's divide by 3 first. So that's ln of 2x equals 4. Remember that the base on an ln is e, so to change that to an exponential, it's going to be e to the 4th equals 2x. Divide by 2, so e to the 4th over 2 equals x. Oftentimes with e, we just leave it as e and we never actually find out the decimal. So just keep that in mind. Okay, so now you have 2 over here that I would like you to try. So pause the video and give them a shot. Okay, so hopefully you have 2 to the 3rd equals x minus 4. 2 to the 3rd is 8. X equals 12. Over here, we're going to divide by 4. ln of 3x equals 2. E squared is 3x. So x equals e squared over 3. Okay. Now we have multiple logs. So that's where the condensing rules come in. This is exactly why you had to condense a log, or you had to take multiple logs and write it as a single log, because right now your x's are all over the place, so you got to collect them. So we're going to take the left, and we're going to make it one big log 2. So in parentheses, we're going to have x. Remember, the plus turns into a times. X minus 7. Okay, so 2 things here. We have 2 to the 3rd, and then equals all of this stuff, but we can multiply that out and get x squared minus 7x. So I hope you see what's happening here. This is 8, and now this is a quadratic. So you have to solve it like a quadratic. Okay, but you need to check your answers. I should have checked them up top. I really should have, and I just kind of forgot. But okay, so x is negative 1. Let's look at that one first. That would have to go here. Log base 2 of negative 1. Why don't you type that in your calculator and see what it says? It says error, because you can't take the log of a negative number. So this is fake, not for real. You gotta let that go. Put in the 8. The 8's okay. Usually what happens is not that you get a wrong answer, you just get something that doesn't work. So you try to put in the negative 1, can't take the log of a negative number. You can put in the 8. I don't actually do out all the work to make sure 8 works, because odds are 8 works. You just need to make sure that you're not going to take the log of 0 or a negative number, because you're not allowed to do those things. Okay, let's come over to this one. We're going to start by making it one big log. This doesn't have a base, so it must be a base of 10. So that's 10 to the 1 equals x squared minus 3x. Move the 10 over because it's a quadratic now. It's going to be a minus 5, a plus 2. So x equals negative 2 and 5. But you need to make sure you're not going to have to take the log of a negative number. That's going to be the log of a negative 2, so that's a no. So you're going to have to stick with the 5. And that, my friends, is... No, not the end. Oh, I missed a page. Oh, there it is. Never mind. I was like, it's over. One of my pages didn't get stapled. So this next set of problems is when there's logs just all the heck over the place. So, like if you look down here at example 8, you have log, and then log on that side as well. So that's going to require more work. So on the left and on the right, you want to isolate the logs. So you want to condense all the logs on the left, condense all the logs on the right. So that it's log of something equals log of something. Okay, just like with the exponents, remember how if we had, e to the 2x equals, e to the 3, then as long as these bases are the same, then, just 2x equals 3. Well, it's, it works the same way for logs. So if you have, log base b of m equals log base b of n, then m has to equal n. Excuse me. So then you can just take everybody out of the log and then you solve. But again, don't forget to check because you might get somebody who doesn't really work. All right, let's give this a shot. So on the left side, I have 2 logs. So I'm going to change that into 1 log. This is a minus, which means this is going to be division. The top will be x plus 2. The bottom will be 4x plus 3. There's nothing we can do with the right side because that's just a single log already. So now I have ln of something equals ln of something else. So I just can get rid of the ln's now. I don't need them. X plus 2 over 4x plus 3 equals 1 over x. Now this could be a daunting task in and of itself, but what I would do is I would cross multiply. So I would say x times x plus 2 equals 1 times 4x plus 3. Distribute. It's a quadratic again. So I'm going to move these people over. So that'll be minus 2x minus 3. Little baby factor problem here. Minus, plus. Okay, and then check to make sure they're both going to work. So let's see here. The negative 1 is suspicious for sure. Let's put negative 1 here, though. If I put negative 1 there, I still have a positive number in the log, so that's actually okay. If I put a negative 1 here, I get negative 4 plus 3, which is negative 1, so the negative 1 doesn't work. So I'm crossing him out. But a positive 3 is okay, so it's just going to be positive 3. All right, let's try this one. On this one, I have a single log on the left, but I have multiple on the right. Again, this one is going to be division. Just look at the sign before the log. If the sign before the log is minus, the thing is going to go on the bottom. If the sign before the log is plus, it goes on the top. Okay, so you're going to have to cross multiply. Just pretend there's a 1 down there. FOIL, so x squared minus 3x plus x minus 3 I'll clean up this side. I'll subtract this, subtract the 7x, that'll be minus 9x, and I'll have to add the 20. I'm sorry, I'll have to add the 23, which will then become a 20. And then factor. Now see, in this one we've got positive numbers, so I'll bet these both work. So if I put 5 up here, yep, that's all good. If I put 4, that's still a positive. That'll be 28 minus 24, that's fine. 4 plus 1 is 5, that's fine. So in this case, see, they both worked. So you do have to check. Okay, and then down here we just have some vocab. I know these come up on the quizzes, so I thought, well, why not just have you do them ahead of time? So let's see here. So if b to the m equals b to the n, then m equals n, right? If you have the same base to different exponents, and the exponents are equal, if x ln 9 equals ln 20, then x would equal ln 20 over ln 9. If e to the e to the 0.6x equals 6, then ln of 6 equals 0.6x. If log base 5 of x plus 1 is 3, then 5 to the third is x plus 1, or you could say 125. Okay, this is going to require some condensing. So that's going to be x squared plus x. Isn't this the one we just did? That's really weird. They can't even make up new problems? That's pathetic. Okay. Okay. I like these. True or false? X to the fourth equals 15 is an exponential equation. The answer to that is false, and that is because the exponent is not a variable. An equation is exponential if its exponent is a variable. So 4 to the x is 15. That is an exponential equation. True or false? Negative 3 is a solution of log base 5 of 9 equals 2 log base 5 of x. Okay, I don't even have to solve this. If negative 3 is an answer, then that means there would have to be a negative 3 there, and you can't have the log of a negative number. So there's no way that negative 3 is an answer. False. And my reason was negative 3 is not in the domain of log base 5 of x. Okay, but what about this one? Now it's a negative again, but if you put the negative in for x, that's still a positive number. That would just be log base 5 of 25, and that is okay. So you can't just look, say, hey, it's negative, it must be wrong. You do have to do a little bit more investigating than that. So this week, you're going to have 2 assignments on solving log equations, log and exponential equations. So if this video was long, I apologize, but you're only going to have 1 video this week. So make sure you're practicing your solving log equations and come with questions.